I'm Sylvain Moulherat from TerrOïko.
So this is about the sensor-based data collection.
The French Ecological Engineering Professional Union.
The future trends
and I will
according to the BISON project.
some of the results of the BISON project, where I lead the task dedicated to the digitalization issues. The BISON project is a €3 million coordination support action granted by the H2020 program, which aims at developing the strategic research and deployment agenda to improve the mainstreaming of biodiversity in the transport infrastructure lifecycle. The project involves 44 partners and 6 third parties from 16 countries and has a duration of 30 months. The project has started last year in January, so we are about in the middle of the project today. The digitalization theme is vast and already benefits from many European strategies by its own and by sectors. So in the BISON project, we didn't aim at discussing and developing it widely, but rather focus on specificities related to future research and deployment requirements, permitting the integrated management of biodiversity and transport infrastructure in the digital environment. So to resume what we developed in this BISON's task, we try to integrate biodiversity management in the existing BIM and digital twin world, and we try to introduce the BIM concepts in the biodiversity management sector. In this respect, we use 4 main development axes to sensibilize our targets and identify the future needs of research and deployment. We initiate a common representation of what could be an inclusive BIM or digital twin for biodiversity and infrastructure to provide an expected ideal situation by 2015. We stress the synergies and mutual benefits expected with the digitalization of the 2 sectors. We propose pathways to integrate BIM and digital twin concepts in the biodiversity sectors and biodiversity as a theme of the BIM and digital twin users and developers. And finally, we propose some basis for future common culture. So, to develop each of the presented axes, we used a simple methodology. We conducted a non-systematic literature review completed by a stakeholder survey, which allowed us to design a first set of vision of the future on our topic and to link this vision to research and deployment needs. These preliminary results have been presented and debated in a brainstorming session with the project advisory group members, composed of international experts of our topic, not members of the BISON consortium, to feed the final vision and research proposal developed in the final task report. In this task, we mainly developed 3 main aspects of the mainstreaming of biodiversity in transport infrastructure in the digital world. First, the data and its collection, then the data management, its storage, normalization, etc. And finally, its use in the digital model. In this presentation, I will only focus on the data collection aspect, while my colleague Frédéric Jehan from Egis will develop in another talk the data management and its use. So first, we address the use of sensors to produce raw data, and more specifically what we call the mobile remote sensing. In this type of data collection, the principle is that sensors are embedded on mobile vectors of any type, such as satellites, drones, cars, animals, etc. Our work highlights that these techniques are well known in the research field in transport infrastructure management as well as biodiversity management, but it is not so used in the day-to-day life of biodiversity managers. As an example, we showed in a recent paper that up to 70% of the expert-based indicators used in the main ecological equivalence methods used to design compensation measures could be replaced by more robust and replicable ones based on mobile remote sensing techniques. In addition, the data produced for one purpose are rarely and hardly used for another one. For example, LiDAR data produced for topological use, for example, are rarely also used for tree species identification, for example. In parallel, we also pointed out the fact that to date we used to use a single type of sensor for a single usage, while coupling different sensors is expected to strongly improve the performances in detection of elements of interest. We thus questioned our current practices and identify the need for process and techniques improvements, but also tools, and particularly digital tools, contributing to solve this loss of efficiency and resources. This discussion also pointed out the opportunities offered by the development of individual autonomous vehicles, which need a lot of sensors, but will raise up new question about privacy, data sharing regulation, etc., etc. Second, we discussed the potential of static remote sensing. In this case, we mainly consider static sensors connected to each other and or to a master element such as an infrastructure or a vehicle. Connected sensor is also known under the designation of IoT, which allows for continuous and large-scale monitoring systems. In this case, synergies seems requiring more research effort to be as useful for biodiversity management than for transport infrastructure in the context of infrastructure management. Indeed, if direct measures are often sufficient for transport infrastructure management, they almost systematically need further complex additional analysis to be used for biodiversity management. We thus highlight, for example, with this technology, some research needed in the field of statistics. Indeed, to date, most models used to survey population of species are based on a discrete time basis. With the deployment of static sensors, continuous monitoring based on such technology would require adaptive analytical abilities, which are for now in the prime age. We also imagine global biodiversity monitoring systems based on the interaction of sensors networks from different infrastructure, which also raised up research questions in the field of human science, law, telecoms, etc. Third, we address the citizen-based data production issue and point out that if such data collection process is common in the biodiversity sector, it is not the case in the transport infrastructure management one. Developing this, we come to the conclusion that it will probably have few future for the infrastructure management. So synergies seems limited on this type of data collection, but must be addressed this kind of data must be addressed in the development of the future common culture and future tools. The fourth main source of data we explored are data provided by engineering models. Such models are expected to be highly realistic and used to solve engineering problems. They are commonly used in the industry and civil engineering, but most ecological models do not fit the characteristic of engineering model. So, even if most ecological models cannot be considered as engineering models, we pointed out the fact that most of them are hard to use and useful to mainstream biodiversity in transport infrastructure. And sorry, as they're hard to use in the day-to-day practice on the field, and thus we would like to improve their embedding in GIS, BIM, and digital twin tools, which would probably improve the ability of mainstreaming biodiversity in the transport infrastructure lifecycle. So here again, we pointed out major needs for future digital needs in research and deployment. Finally, we conclude our discussion in this task on data collection with the transversal topic of artificial intelligence. We show that AI will soon be the first treatment on the raw data and constitute a major process for building secondary data exhibiting high added value. But I won't develop more this section because research and deployment needs on this topic are, for most of them, not specific to the integration of biodiversity in transport infrastructure management. So we discuss it in the report, but I won't develop it too much at this point here because it's part of the EU digital strategy and so on. So to close this part of the discussion, I suggest you to follow Frédéric's talk to have the rest of the story. What will we do with this data, or to go in deeper details by reading the report available soon on the BISON project website. Thanks for listening.
Hello, hello. No. Thank you, Sylvain. I hope your voice recovered a little bit. There's space for some questions, so please. Yes?
Yeah, my question is, so we've been discussing this a lot in Germany, monitoring verges, but the question that always comes up is who's going to do it and who's going to host the data? So if we have like a BIM for biodiversity data, especially for infrastructure, which I think we need, the question is who's going to do it and who's going to host the data and how often is it going to be done, like if you do some kind of monitoring? Are there any ideas on how that is going to work?
Thank you, Andres. I'm not sure I get all the questions. So the question was, who will do the monitoring? Who will provide the data and so on? Yeah. Yeah, sure. So it's a BISON project. So it's one of the perspectives. So to date, we cannot answer directly. But yes, it's a main issue. In the current practice, I don't know if in Germany, but in France, for example, it's people doing this study who are the data provider. There are many contracts where the digital model is part of the building for new infrastructure and so on. I think it's the same in Germany now. Yeah. So in that case, it will be the infrastructure manager who will be more or less the responsible for the digital models. He can have a subcontractor, but it's often the infrastructure manager who is in charge of dealing with this. And for, I would say, the maintenance of the digital model and the embedded data, I think once again it will be probably the infrastructure manager who will order for the monitoring and the survey. So maybe Frédéric will have complementary answer on this because he's more aware of this kind of thing because he's a BIM manager and I'm not. But in my understanding, it's more or less the case to date.
It's going to be short. So you were talking about deep learning and using, for instance, Naturalist. We heard a talk on the first day from Finland, from Maila, where she couldn't use part of the data because there's too many images to analyze. Now, that shouldn't happen. We should have the software provided for any company or that can just run it. For instance, in Switzerland now, we have census along our highways with images and deep learning, Aliantes Altissimus and Senetio Eniquedets. And we now have the deep learning part. The question is, how do we transfer that from research into something that everybody can use? Because it needs a lot of servers. And this needs to be solved not on a NRA basis, not on a country basis, because it's going to be the same images all over. It needs to be solved on a European basis. Do you see where this can happen and be hosted, like Naturalist, for instance, or PlantNet, etc.?
Yeah. I have a talk on this afternoon, but there can be many solutions and many different problems, because if the question is just about how to store and use the often convolutional neural networks, it's quite light in terms of data. Just the neural network architecture is nothing. And it can be embedded into the digital model. So when you have your data set coming from a cam trap, you can analyze it. I won't say easily, because you need big machines to do this, and it can be time consuming. But we can also have some services to rent somehow. Not data center, but HPC computers has services. So it's a possibility. We can make the link in the digital models, for example, and it was part of the engineering model section. So this is one solution. Concerning the main problem is not on the use of a neural network, but on the training, because for training we need very large data sets and we need very powerful computers. And this kind of things should be, we can expect being able to share the resources on this. So for the French party, we have this kind of dynamics ongoing. So with mutualization of data and resources for HPC, so high performance computing. So there are some infrastructure processes and so on which have been started, initiate, and it can be considering information technologies, it can be relatively easily spread out of a single country and expanded to larger scales. So, thank you very much.
Thank you, Sylvain. We move on to the next speaker.